Message haki group ali, WhatsApp group ali. Let's just join. Okay, and started deriving the moments. So mu1 dash, the first round moment about the origin is expectation of e to the power of x and observed that is equal to p. And in general, we observe that mu r dash, which is expectation of x to the power of r, that is r's moment about origin, that is also equal to p. So we'll prove that. So we can directly state mu2, mu3, and mu4 dash. So this will be x to the power of r into probability. Now for this case, my x is taking only 0 to 1. So this will be equal to summation over x equals 0 and 1, x to the power of r into p to the power of x, 1 minus p to the power of 1 minus x. When I put x is equal to 0, I get 0 power r, p to the power of 0, 1 minus p to the power of 1 minus 0, plus 1 to the power of r, p to the power of 1, 1 minus p to the power of 1 minus 1. So this becomes 0 plus p, which is equal to p. So the r raw moment about origin for a Bernoulli distribution is always equal to p, which is probability of success. Therefore, we could say the first four moments are same. First four moments about the origin, they are all equal to p. Now, since we have these cases, now easily we could obtain the other moments. So we obtain mu1, that is always 0 for the distribution, which is the first central moment. Second moment, which is same as variance, is mu2 dash minus mu1 dash square, which comes to p minus p square, or is equal to p into 1 minus p, or p into q. Similarly, if you look into the third central moment, which is mu3, that is in the formula mu3 dash minus 3 mu2 dash mu1 dash square plus 4 mu1 cube bar. It's 2 mu1 cube. So when you substitute that, you get p minus 3p into p square plus 2p cube. Mu1, mu2. So this is equal to p minus 3p square plus 2p. So you can simplify this into a neat form by taking p outside. So I'll get 3p plus 2p square. Now you can factorize this form and you will get that as p minus 1 into p minus 2. So you have 2p square minus 3p plus 1. So you can write this as 2p square minus 2p minus p plus 1. And this becomes p minus 1. And if you take minus 1 outside, you get p minus 1. So this is 2p minus 1 into p minus 1. So you have this as p into 2p minus 1 into p minus 1. That is your mu3. Or also you can write this as p into, now what I do is I take 2 outside here. So I'll write 2p into p minus half into p minus 1. Or I can write this as 2p into half minus p into 1 minus p. 1 minus p can be taken as q. So I can write this as 2pq into half minus p. So this is our mu3 simplification. Now why we are writing like this? Because we can express that in terms of mu2, and Also, we could look into the cases where mu3 is greater than 0, mu3 is less than 0, and mu3 equal to 0. Because our skewness is based on this third moment mu3. So, without computing mu3, just by looking into the value of p, we could comment what is the type of the skewness. Now, compute mu4 similarly and simplify it like this. So you'll get terms, factorize them, and see what you get for mu4 and derive it. Try ಮಾಡಿ ನೋಡೋಣ. ಹೇಳಿ ಏನ್ ಬರುತ್ತೆ mu4 ಗೆ. ಬಂತಾ ಹೇಳಿ ಫಾರ್ಮುಲಾ ಹೇಳಿ. ವಾಟ್ ಇಸ್ mu4 ಫಾರ್ಮುಲಾ? Fourth moment mu4 dash minus 4 mu3 dash mu1 dash square. Plus 6 mu2 dash mu1 dash square minus 3 mu1 dash power 4. So all these raw moments are p, so substituted and simplify. Simplify ಮಾಡಿ ಹೇಳಿ ಏನು ಬರುತ್ತೆ ನೋಡೋಣ. So you get p minus 4p into p plus 6p p square minus 3p power 4. So I can take p outside. So I'll be left with 1 minus 4p, and we'll have 6p square minus 3p cube. Now you have to somehow bring it to a simple form, like as we did in the case of mu4. This is a cubic equation, and it looks though that your p is equal to 1 is a root, so you can factorize this in terms of p minus 1. So I have minus 3p cube plus 6p square, then plus minus 4p plus 1. And if you see that
synthetic division ಮಾಡಬಹುದಲ್ಲ ಸರ್?
ಅದೇ. So you have 4 and minus 3, 7, 1 and 6, which is plus 7. So if you put p is equal to 1, you will that satisfies the equation if you write that. So p minus 1 is a factor. So what you can do is you can multiply by p square minus 3. So you get minus 3p square plus 3p square. And when you subtract, you get 3p square minus 4p plus 1. So you multiply by 3p, get 3p square minus 3p. So you get minus p plus 1 minus 1 minus p plus 1. So you can write this as p into p minus 1 into minus 3 p square plus 3p minus 1. Now see whether we could factorize this further. Four by mu 2 square p. So let us the factorize ಆಗಲ್ಲ. So we'll keep this and we'll look into the value of our beta 1 as well as gamma 1. So beta 1 is defined as mu 3 square by mu 2 cube, and we have just derived our mu 3 square. What was that? I just erased it. So we had 2pq
2pq half minus p.
minus p whole square divided by mu 2 square. Mu 2 is pq, right? pq square. So this complete
pq cube allo sir.
huh?
pq cube allo sir.
Cube. So we'll be left with 4 into half minus p whole square divided by pq. So 1 pq cancel out. So that is our beta 1. And also we have gamma 1 is equal to square root of beta 1. So gamma 1 will be square root of 4 into half minus p square by pq. So which will be 2 into half minus p divided by pq. Hope the result is correct. Q minus p by square root if we go. Or you can write this as 1 minus 2p divided by root pq. 1 minus p na, you could write that as q, and also you can write that as q minus p. So several forms are there. So example prove that gamma 1 is equal to this or this in other forms. So you know that q is equal to 1 minus p. So you can express that in the various forms. Now how to comment using on the skewness using this relation. Now measure of skewness is taken as beta 1 as well as gamma 1. So we say if beta 1 is greater than 0 or gamma 1 greater than 0, that indicates positive skewness. Now if I say I am observing the value of positive skewness, So I mean my this 1 minus 2p by root p cube must be greater than 0. So this implies 1 minus 2p is greater than 0, or 1 greater than 2p, or p less than half. Sorry, Alva. So when I send to this side, I get half greater than p of p less than half. So what we have is, if you just observe the value of p without even looking into the values of beta 1 and gamma 1, you could say what type of skewness is. For the negative skewness, similarly, gamma 1 will be less than 0. Gamma 1 less than 0 implies p will be greater than half. And for no skewness, if I say beta 1 or gamma 1 equal to 0, then I'll get 1 minus 2p equal to 0, or p is equal to half. So you compare the value of p with respect to half, and you will say whether the distribution is positively, negatively, or no skewed. Okay. Now obtain beta 2 and look into the kurtosis. There is one. No. Okay. So I need this, so I'll keep it. Similarly, if gamma 1 is less than 0, so I'll have 1 minus 2p by root p cube less than 0, or p greater than half. So if gamma 1 equal to 0, this implies p is equal to half. So hence, we say if p less than half, distribution is positively skewed. P greater than half, distribution is negatively skewed, and P equal to 0, sorry, equal to half, distribution is symmetric or no skewness. A P less than half implies P is less than Q, or Q greater than half. Similarly, P greater than half, if P is greater than half, obviously Q will be less than half. So in that case, P is less than Q. So we can talk about the skewness just by comparing the value of P and Q. So P equal to Q, no symmetric, and this case is same as P less than Q. The same as case is same as P greater than Q, and this is P equal to Q. Similarly, you can compute the value of your beta 2, which is mu 4 by mu 2 square. So that becomes p into p minus 1 into ಸರಿ ಬಂತಾ ಇದು mu 4 ಎಲ್ಲರಿಗೂ ಇಷ್ಟ ಬಂತಾ mu 2 square. So pq whole square. So you can write this 1 minus p as minus q, and you can send that minus 1 inside. So you will have 3p square minus 3p plus 1 divided by pq. Or you can write this as by p minus p square by substituting that, and you can compute gamma 2, which is beta 2 minus 3. So that is equal to 3p square minus 3p plus 1 by p minus p square minus 3, or that will be 3p square minus 3p plus 1 minus 3p plus 3p square, all divided by p minus p square. And simplify that, that will get you the excess kurtosis. ಸೈನ್ಸ್ ಎಲ್ಲ ಸರಿ ಇದೆ ಅಲ್ವಾ? ಒಂದು ಟರ್ಮ್ ಕ್ಯಾನ್ಸಲ್ ಆಗ್ಬೇಕಿತ್ತಲ್ಲ. Check your mu4 calculation and tell me whether it is correct. Minus 3pq plus 6p square minus 4p plus 1. So what's that our mu4? So this should come to 1 minus 6p by pq. So this 3p square should get cancelled. And why is it not happening? P into 1 minus pp minus p square. So minus of 3 into p plus 3p square. What that? Minus 3p square per 8. Check ಮಾಡಿದ್ದು calculations. ನಾನು ಇನ್ನೊಂದ್ಸಲ ಮಾಡ್ತೀನಿ ನೋಡಿ. So we'll use the final result, which is gamma 2 equal to 1 minus 6p by pq. So gamma 2 greater than 0 implies p should be less than 1 minus 6, p equal to 1 by 6 and p greater than 1 by 6 respectively for the lepto, meso and platycardi. So ಅದೇ ತರ derive ಮಾಡಿ the 3 cases for kurtosis and check this result. So even I'll do that. So some mistake in mu4 that has to be rectified. Let me see. So this is about the moments, mean, variance and the properties of Bernoulli distribution. Now we'll look into the other case, that is the cumulative distribution function or f of x of Bernoulli. Now f of x is defined as probability that x less than or equal to x, and we have the distribution as p of x is equal to summation over x equals 0, 1 p to the power of p to the power of x 1 minus p to the power of 1 minus x. So when I say p x less than or equal to x or x less than or equal to 0, because my value of x are either 0 and 1. So this, there is only one case which is x is equal to 0. So this will be p to the power of 0, 1 minus p to the power of 1 minus 0, which is equal to 1 minus p. And the next case is p of x less than or equal to 1. So this will be same as p of x equals 0 plus p of x is equal to 1. So we know that the total probability is 1. So that comes to 1. So you have the distribution function for Bernoulli variable as 0 ending at 1, and in between you have 1 minus p. So this is for less than 0 if your x is equal to 0 and between 1, and for any x greater than or equal to 1 or you could say 1 less than x less than infinity, you will have f of x as 1. So this is how you mathematically evaluate the CDF. Again, x values ಇರುತ್ತೆ ಒಂದೊಂದಾಗಿ ಫಾರ್ಮುಲಾ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಕೊಂಡು ಹೋಗಿ ಆ probabilities evaluate ಮಾಡಬೇಕು. So we have x is equal to 2. X is equal to 2 values, that is 0 and 1. So first we'll say what happens to the distribution function at x equals 0, at x equals 1, and then we'll evaluate. Okay, so what else we have? Properties, distribution, moments, skewness, kurtosis. Then we have MGF, MGF of the Bernoulli distribution. MGF is expectation of e power px. So we have px is equal to this. So expectation of e power px will be, by definition, summation over x e power px into the respective probability, and in this case it will be equal to summation over x equals 0 to 1 e power px t power x 1 minus t power 1 minus x. So when I put x equals 0, I get t0 b0 1 minus t power 1 minus 0. When I take x is equal to 1, I get e power t into p power 1 into 1 minus p power 1 minus 1. So this is 1, so I'll get 1 minus p, and this is 1, so I'll get p power p. Or you could say q plus p power p. So this is the MGF. Mx of t is equal to q plus p e power p. So again results derive ಮಾಡಿದೀವಿ, ಅದೆಲ್ಲ ನೀವು ಜ್ಞಾಪಕ ಇಟ್ಕೊಂಡಿರ್ಬೇಕು. So questions could be derive the MGF of Bernoulli distribution. Derive the MGF of Bernoulli distribution, and further they could say hence obtain moments from the distribution. First 4 moments in the cable. So we know how to obtain the moments from the MGF. So we have to differentiate. So deriving moments from MGF. So we have mx of t is equal to q plus p e power t. So the first moment mu1 dash is equal to derivative of mx of t with respect to t. T is equal to 0. So when I differentiate this function with respect to p, so derivative of q becomes 0 and p into e power p. So when I put t equals 0, I get the first moment which is equal to t. Now similarly, mu2 dash is second derivative of your mx of t at t equals 0, which is same as the derivative of the first derivative. First derivative is p e power t. When you differentiate p e power t with respect to t, you'll get back the same. So this is again equal to t. So we observe that the rth or the kth derivative of the MGF always produces p e power p of. I could say in general, any mu r dash, which is the rth derivative of the MGF at t is equal to 0, that is also p e power t at t equals 0. So the r moment about origin is also equal to p. Now after observing mu1 dash, mu2 dash, mu3 dash, mu4 dash, you can compute mu1, mu2, mu3, mu4 as well as beta 1, beta 2. So looking into what is asked in the question, how many marks it carries, you have to do the derivations. Just first for raw moments we'll see. Compute the first 4 central moments from the MGF after obtaining this, compute mu1, mu2, mu3, mu4. And if they say derive beta 1 and beta 2 for a Bernoulli distribution, then either you could start from the MGF like this, or you could use the previous method where we obtain mu r dash using the formula expectation of x power r, and we obtain mu1 dash, mu2 dash, mu3 dash, mu4 dash is equal to p, and again can use the formula or the relation between rho and central moments and can derive beta 1 and beta 2. So this completes almost of the properties of the Bernoulli in an arbitrary first chapter allow the definition में we know mode with it, mode and median, and also the probability generating function. So we'll have the probability generating function. So we haven't discussed much about this. So I'll take a class and I'll do that. So it is defined as expectation of x power x, which is equal to summation x is belonging to s, x to the power of x into px. So this will be summation x equals 0 to 1 s to the power of x, p to the power of x, 1 minus p to the power of 1 minus x. When you have your s as 0, x as 0, so you get s power 0, p power 0, 1 minus p power 1, plus s power 1, p power 1, 1 minus p power of 1 minus 1. So this is q plus sp. So this is your PTF of Bernoulli distribution. So this is called as probability generating function, because when you differentiate this with respect to s and put s is equal to 0, that will generate the probabilities, as well as it will generate the central moments. ಇದೊಂದು pending ಆಗ್ಬಿಟ್ಟಿದೆ, ಕಂಪ್ಲೀಟ್ ಆಗಿ ಡಿಸ್ಕಸ್ ಮಾಡಿಲ್ಲ. We'll look into this. Now talking about mode, how do we define mode? Mode is the most repeated value of a distribution, or when it comes to probability distribution, it is the value which has the maximum probability. And there are only two values here, 0 and 1 for x, and two probabilities q and p. So we say mode equals 0 if you have q as the lesser value, or q as the greater value compared to p, because when I say q greater than p, then this will be the maximum probability, therefore 0 becomes the value of mode. Q greater than p also implies that p is less than half. So if p less than half, we'll have the value of q greater than half. If on the other hand, if q is less than p, or p is greater than q, or p greater than half, or q less than half, then the mode of the distribution will be equal to 1. So just look into which value is high. Q ಜಾಸ್ತಿ ಇದ್ರೆ 0 mode ಆಗುತ್ತೆ, p ಜಾಸ್ತಿ ಇದ್ರೆ 1 mode ಆಗುತ್ತೆ. So for a specific value of p, we could obtain the value of mode. Similarly, if you look into median, median is the value of x such that it has 0.5 probability when we take the total. So we had our f of x, which is the cumulative distribution function, as 0, 1 minus p and 1. So we say median is a point x, or could say m, such that our f of m or p of x less than or equal to m is equal to 0.5. But since it is a discrete distribution, exactly equal to 0.5 cannot be observed, so we take slightly greater than 0.5. So now to obtain median, now if I have my this 1 minus p as any value slightly, greater than 0.5, then we could say that x is equal to 0 becomes the median. So if 1 minus p is greater than 0.5 or q greater than 0.5, then x equals 0 is median. Else the other case could be our 1 minus p less than 0.5 or our q is less than 0.5. In that case, x is equal to 1 is the value of median. उल्टा अगर median case के लिए mode case